Okay, so we have to integrate this expression here, 1 plus x to the power 4 divided by 1 plus x to the power 6 with respect to x. So the first thing we look at is, let's say, the denominator. I have 1 plus x to the power 6. Now x to the power 6 can be expressed in two ways. It can either be x cubed squared or x squared cubed. If I think about it as x squared cubed, then the denominator becomes a sum of cubes. 1 plus x squared cubed. And then I can factorize this using my sum of cubes identity. Now if I do that, what I would get is, as one of the factors would be 1 plus x squared, and the second factor would be 1 minus x squared plus x to the power 4. Let us just keep that aside. If I treat x to the power 6 as a square, and I say that that's actually x cubed squared, then I have 1 plus x cubed whole squared. Now if I think about x cubed as the variable, then I need to have a 3x squared, or at least an x squared in the numerator, so in order to be able to substitute it and get a complete substitution easily. But I don't have that in the numerator. I don't have an x squared term. However, I can introduce it by adding and subtracting x squared. I can add and subtract 2x squared, in fact, so that I have 1 plus 2x squared plus x to the power 4, and then I have to subtract and have minus 2x squared also. Now the 1 plus 2x squared plus x to the power 4 is simply 1 plus x squared whole squared. Now you remember when we had factorized the denominator as a sum of cubes, we had a 1 plus x squared term there. Yes. Now this probably lets us know that we should be using x to the power 6 both as a cube term, that is x squared whole cube, as well as a squared term, that is x cubed whole square. So let us do that and see what we are going to get. So doing exactly what we said, adding 2x squared and subtracting it in the numerator, factorizing it as a sum of cubes, so 1 plus x squared, 1 minus x squared plus x to the power 4. So that first three terms in the numerator become 1 plus x squared whole squared, and then I have the minus 2x squared by itself. Now I'm able to split this into two different integrals. So I have 1 plus x squared here, and the 1 minus x squared plus x to the power 4, because one of the 1 plus x squared terms will cancel in the numerator and denominator. And then the second expression would be minus 2/3, and I would get 3x squared divided by 1 plus x cubed whole squared. Remember, here we're going to take x cubed as our variable. Now in this first expression, I can divide by x squared, the numerator and denominator, and then since I'm getting 1 plus 1 by x squared here in the numerator, I will convert this by completing the square into x minus 1 by x whole squared plus 1. The second term remains as is. Now in the first expression, we will let x minus 1 by x equal to some variable u, which means 1 plus 1 by x squared into dx is equal to du. In the second expression, we let x cube equal to some variable v, and so 3x squared dx will be equal to dv. So what this reduces to now is the integral du by u squared plus 1 minus 2/3 integral dv by 1 plus v squared. And this is trivial. The standard results give this as tan inverse u minus 2/3 tan inverse v. U was x minus 1 by x, v was x cubed, and so we get tan inverse x minus 1 by x minus 2/3 tan inverse x cubed plus c.